Okay, now let's consider the x-coordinate of this point is 4. So everywhere in the plane parallel to the YZ plane that goes through this point, x is going to equal 4. So what's the curve, what's the intersection of the graph of this surface with this plane? Whatever it is, it had better have a slope of 0.15 at this point. So it's going to be some kind of a curve, maybe like this, maybe who knows. We'll see in a minute. What is the curve that you get if you intersect the surface with the plane x equals 4? Well, if x equals 4, then f of xy is 4 plus the square root of y. So x equals 4, we have 4 plus the square root of y, and that equals z, because of course we're looking in the yz plane. The value of the function is the z coordinate, so since when x equals 4, the value of the function is 4 plus the square root of y, we say that the z coordinate will be 4 plus the square root of y. And then similarly, when y equals 9, then we're in this plane. Whatever curve we have is going to be parallel to this segment or to this u vector at this point. What is that curve in the intersection of the surface with the plane y equals 9? Well, if y equals 9, then square root of y is 3, and you have z equals f of xy equals x plus 3. So, if y equals 9, you're in the plane z equals x plus 3. This is the plane z equals 4 plus square root of y. And now we can talk about the behavior of the function in those planes and what that has to do with our picture here and our tangent plane and our ability to visualize the function. Another way of looking at these intersections. Okay, remember we've got these parabolas. If this is the origin, we've got a parabola here with its vertex in the origin in the xy plane, and then we go to higher and higher planes, we get similar parabolas, but they're further and further in the x direction. If we look at the point where x equals 4 and y equals 9, well, let's just say x equals 4, here's the origin, x equals 4, let's say here. Okay, well, we slice this surface with this plane. Okay, what do we get? And then we slice it with the plane y equals 9. So we come out to y equals 9, we slice it here. Now we have a slice here and a slice here, and those two slices meet right above the point where x equals 4 and y equals 9, and we have our tangent vectors. We've already figured out our tangent vectors. So you want to try to reconcile that, you want to try to think of that. Unfortunately, I don't have a three-dimensional model handy. Too bad we don't have good laser technology here where I could actually put that in front of you. Okay, well, we have, just put this up here. We have here a picture of what you get in the x equals 4 plane. This is a graph of z equals square root of y plus 4. And this is a graph of z equals x plus 3. This is what things look like in that x equals 4 plane. That plane intersects this curve or this surface in a curve that looks like this. Just within that plane, right there's your curve. We intersect this plane with a straight line, basically. So within this plane, you're looking at a straight line. You're looking at this straight line, or you're looking at this curve. So we'll go on with this idea in the next clip.